Thank you very much for the introduction. Hello, everyone. This is Xiaonan Wang from Singapore, National University of Singapore. So today my topic is energy and environment resilience facing COVID-19. It's really a great pleasure to join this panel, to be invited with experts from ADV and applied energy to discuss the important topics at this stage facing the COVID-19 and past pandemic. What are actions? I hope through my talk, I really raised several different aspects, and I hope to share some ongoing work with you, especially to see what's the role of data science in this pandemic and post-pandemic. Okay, so to start with, we have discussed a lot about sustainable development goals, about increasing population, energy demand, and waste accumulated, and a lot of adverse events, including the extreme weather conditions and the pandemic, are happening this year in this 2020. So we see a global trend of increasing temperature, and we see the how to fight climate change. It's a race we can win through our generation, the last generation, that we can take actions to keep the temperature increase within the 1.5 to 2 degrees. So this is the overall aspects we could do to deal with climate change. And when we face the COVID-19, I really we were very anxious at the very beginning and to see the global pandemic happening. Well, some different aspects to look at the positive side was a reduction of the CO2 emissions. Right, so this series of papers really call out attention to see the decrease in CO2 emissions at the beginning of the COVID due to the reduction of the manufacturing industry and the human activities. Like the previous talks presented in Japan, in the States, the excellent researchers have shown the data-driven research to really show the evidence of the reduction of the CO2 emissions. And a lot of research has been done focusing on China, United States, including many countries, to show the reduction during the first half of the year, especially for this series of research until April. We really see the reduction of emissions in different sectors, several key sectors. And when we reach the end of the year, now cannot imagine it's already December of 2020, we see the kind of the recover trend, like here now in Singapore and in China, right? We have seen that people's activities are back into normal. So what's the kind of the recover trend? Hopefully in Europe and the States, you're bringing the life to normal soon next year. So we see this different prediction of the recovery scenario. In the past history, most pandemic like the SARS and the Great Worldwide Flu, the V-shaped recovery is was most commonly witnessed. So similarly, this V scenario instead of U or instead L scenario was predicted for COVID-19 as well. So we expect a V-shaped recovery as well. And not surprisingly, we witnessed the recovery of CO2 emissions as well. Therefore, this longer term plan to deal with climate change, to deal with the efficient and the sustainable energy development is still needed. So in our group, we also use a lot of data-driven approach. The previous doctors, Prof. Xie has introduced the data-driven machine learning technologies, right? So we see this era of AI technology has brought a lot advances in different life and the scientific research. Recently, AlphaFold really bring new breakthrough to even protein sense. So we also apply a lot of the deep learning technologies as one branch of machine learning, right, with deeper neural network to analyze the data and also apply them to energy and environment systems. So we have done substantial analysis and estimated that by incorporating the AI technologies, especially intelligent cyber-physical systems into the energy systems, using the technologies through Internet of Things or big data analytics, we could take further reduction of CO2 emissions from all aspects of energy, building, and the comprehensive sectors with more than 50% of CO2 emissions through the utilization of efficient AI technologies. If you're interested, you can read our review and analysis from this work. And with this, we also need efficient tools to manage the data and keep data transparency. We have seen at the beginning, there's a lot of discussions about how we can open the data, especially during the pandemic, not just the increasing disease and infected numbers, but also the global, like the previous wonderful data site Prof. CS team developed. So we need to see those facts. So we also conducted a lot of the initiative to use blockchain technologies to build up kind of an open database for cyber physical systems, for energy peer-to-peer trading systems, so that we can guarantee the data and the information transparency of those data. We don't give, I have no time to give details, but I listed several papers from our group. So if you're interested, you can go to these sessions to see our work presented there. So with this data, we can further analyze for different countries, what's the trend, what's the development plan, what's the energy and the environment resilience. Right, so when we see the global pandemic, we got strong interest in India's case. I have some Indian students and researchers, and I always ask them, how about I remember in April or May, the number of India infected people are just remain the constant, like not increasing. So I ask them, how could this information just be like that? Is that the real information, or is that something we could go deeper to check? So we really studied a lot about India's COVID situation. Right? So in very interesting fact about India's energy system, right? It's quite vulnerable to external changes. I think the Prime Minister announced a pan-India non-mandatory lights-off event to show the respect to the country, to the people. So this is a substantial swing, demand swing, more than 32 GW from the overall national trend and from all sectors. So this caused a lot of interest for us to study what's COVID's impact on energy demand, on electricity sector. So we also did a lot of analysis to forecast the trend of India's different statewide electricity demand. Actually, Dr. gave a very good introduction about the mathematical models in the previous talk. So if you're interested, we also use a lot similar backcast model. But here we use very simple univariate model from the beginning, just to show the trend through different states, using the first-hand data to analyze the impact of different lockdown phases on India's power sector. And we show some interesting results. If you're interested, you can go to the researchers session to really hear about the detailed results. And we really see that reduction that's not surprising, right? We see the over different phases, we see this certain amount of reduction, and then we see the gradual recovery. However, the whole grid is still vulnerable. It's like this is kind of India's kind of representative case for many less developed countries, or even many countries. They still are building up the resilience of their smart grid and power the country. So we really hope to get more understanding about the transparency of their smart grid data, or grid data, not smart yet, and try to understand how these electricity trends reaching normal status after resumption of economic activities, so that contributing to more to the global sustainable development, as its countries account for a lot of carbon emissions nowadays. So this is some analysis we did similar to the other team's work to analyze the data and predict the demand. However, we go a step further. This from here we show some more interesting studies, also motivated by Prof. Yang leading Applied Energy. So we are taking this virtual conference here of ICAE 2020, and this special virtual conference forum really brings a lot of convenience from travel, right? But it also brings a lot of benefits to the global environment. So this is, although we really want to meet together to enjoy the social activities again, this conference actually brings a lot new normal to our researchers' life through the virtual communication. Nowadays, as a new norm during the COVID-19, we see the academic world is also adapting to change very fast. So we switched to conference online. We really want to know how much is its effect on the global CO2 emissions. Is it significant? Are we important by changing this action? So many of you maybe attended the conference last year in Sweden as a very sweet memory with a lot of wonderful activities there. Right? So more than 1,000 attendees from more than 50 countries. But this year, when we fully switched to online, still it's nearly 1,000 of attendees, but this conference on Zoom and through this virtual communication. And then we see next year, hopefully we can again get together in Thailand. The cover paper was just released today, so it's an excellent opportunity also to show the cover paper here. So hopefully next year we can all gather together in Thailand. But showing this trend, what's our effect? What's our researchers' effect by switching conference online? You may have a guess. What's our emissions of the previous conference travel, and what's the emissions of today when we sit in front of our computers, each other at our own home? So here we show some quick numbers. Also, we have 3 papers to be presented in the conference as well. If you are interested, please go to check the results in detail. So here we identified the hotspot, mainly about travel at the conference. During the conference, venue, the hotel, and the food. Right, so travel is really playing a significant role in the carbon emissions. There was such analysis that the total CO2 emissions caused by the air travel for the CASE conference last year was more than 600 tons. It's a significant number. And the average CO2 for per person, each of the participants like us, is around 600 kg. So it's a significant amount of carbon produced. Well, compared to virtual conference, it's less than 0.1% of the total number, right? Because this travel was totally avoided. And this CO2 emissions caused by a local conference venue, we calculated using the economic input-output life cycle assessment to get this overall impact. Still, it's relatively smaller amount, but just caused by the activity. So that we use this case study to offer a robust methodology to estimate the on-site and the virtual conference emissions. We try to bring this tool online so that every conference can calculate their emissions, and then we can kind of build up this carbon market to make our conference greener and offset our carbon emissions. So this avoided CO2 emissions by reduced air travel can be directly visualized. So we use a series of these visualized tools. You can go to the students' GitHub to really check different emission hotspot analysis to see during our activities what's really contributing to the global emissions. Air travel, of course, especially long-haul air travel, causes a lot of carbon emissions by different, by fuel, by airport, aircraft, different aspects. And by making such analysis, hopefully we can be aware of our carbon emissions, and also to perhaps the virtual conference is a good idea, but we still hope to meet again very soon when the pandemic is recovered. Okay, and then based on the human behavior change, we also see a large amount of accumulated waste masks. I think it's a huge issue causing the environment and energy resilience. So previously we have done a lot of analysis focusing on the waste to energy, using the data published in literature or in the research field to analyze what's the trend of waste to energy, how we can valorize the waste, including waste masks, into value-added products. There were abundant research there, so we analyze those research data and use machine learning approach as well to come up with very fast models so that we can analyze based on different feedstock to predict their fuel properties and analyze what's the important features that influence the final energy recovery and the carbon sequestration through the biochar technology, for example, so that we can use those data-driven technologies, also publish as tools to quickly analyze what a biased system through pyrolysis or gasification to get energy recovered even through waste mask. And also, more importantly, we need to think about the future energy and the environment resilience post the pandemic. As energy researchers, we see the energy, like previously, we see the trend published by ADB that the renewable portion is really increasing. That's a good news over the year. So we see combine the renewable technologies, especially hybrid renewable energy technologies with energy storage integrated, and the negative emission technologies like biochar and bioenergy plus carbon capture and storage, together with the waste to energy could combine together as a solution to deal with the climate change problem. So my students also present a series of work. For example, if we organize different systems together as an overall superstructure system, how do we pick the best system design and operation to fit different regions' conditions? We have done a lot of decision-making system development for rural area or urban area like Singapore. We have done a lot of analysis, and it turned out that such a negative emission hybrid renewable energy system could be a good solution for future with reduced cost and even negative emission potential for rural areas and reduced CO2 emissions. So this really calls our attention for future plan post the pandemic. And we also have done a lot of interesting study for the future resilient recovery. So at the very beginning, Jai announced that the vaccine is important to be the final key to deal with the pandemic. However, the vaccine needs the fire efficient distribution over the world. So we studied a lot of those models using our data-driven techniques to analyze the compartment model and estimate the demand for different countries using the parameter fitting and get the future demand. Therefore, based on this, we could model the COVID-19 vaccine global access, the COVAX, as a framework to allow the fire distribution of vaccines once different products are out, and what's a final plan to distribute them to guarantee global access to those vaccines. So through this multi-stage production distribution network, hopefully, we could allow different countries fire access to the vaccine and bring more faster recovery to guarantee a longer-term resilient recovery. So this is a series of work we have done. And just a quick summary for a future perspective, really the COVID-19 has changed a lot of our human activities, energy consumption, and CO2 emissions. So I show a lot of ongoing work we are doing because we see the pandemic and we want to do some actions to link our research to take our responsibility. So we see the data and the information is very important to keep it transparent and open access shared among our community so that we can use those data-driven technologies to analyze, to predict, and propose policy support. And human activities are changing during and post the pandemic. We hoped we can bring new opportunities to reconstruct our energy and the environment landscape. And in the end, we want to get resilient, fair, and efficient vaccine distribution so that we can beat the COVID-19 together and allow the future energy and the environment resilience post-era. With this, I thank my team and fund agencies and happy to discuss questions with you if time not allows, maybe offline. Thank you.
Dr. Wang, thanks very much. Another very impressive presentation with the data analysis. And I think you made a very important point there at the end about the change in human behavior. In a climate change context, especially, we talk a lot about technology and finance and policy, and we don't talk very much about changing public behavior. But changing public behavior is really key. That's if we look at conventional pollution control programs where they've been successful, like in the US, for example, it's really about changing public behavior. The laws and policies and finance and technology are all important, but changing public behavior is what actually makes the difference in terms of the ultimate outcome.